Hello friends, welcome back to my YouTube channel. So in today's video we'll start the new concept, that is moment distribution method. In previous video I have explained the method of solving the moment distribution method. Before coming to this problem, I suggest you to go through that video to better understand of this problem. Our problem: analyze the beam by moment distribution method and draw SFD and BMD. So this is the given beam. So I'll try to explain in very easy method. So this is the given beam. Find the fixed end moment. Our first step is to find out the fixed end moment. Now we'll start fixed end moment. Now we are going for the span A to B. Look at this. This is the span having the point load which is not present at the center. For finding the fixed end moment, we have the formula for A to B is minus WA B square divided by L square, and for also B to A is WA square B divided by L square. So by using this formula, we'll calculate the fixed end moment for AB as well as BA. We'll see. So fixed end moment about AB. So it is anti-clockwise. We have the formula minus WA B square divided by L square. So now substitute all the value. Our load is 50. So minus 50 into our A. This is A. From here to here value is A, and from here to here is B distance. So our A is 4. And our B is 5 whole square divided by our L is total 5 plus 4, 4 plus 5, 9. So 9 square. Simplify this, it will come out as minus 61.72 kilonewton meter. Next will be our fixed end moment about BA. For that it is clockwise. We have the formula WA square B divided by L square. So substitute all the value. Load is, point load is 50, and our A is here 4, square plus B is 5, and total is 9 square. So it will come out as 49.38 kilonewton meter. So our formula for finding the fixed end moment for AB and BA are not same because it is not acting at center. For AB is different and for BA is different formula we have used. And next is span BC. It is carrying the UDL. So for UDL, fixed end moment, calculating the fixed end moment for UDL of span BC, we have the formula. So for UDL we have formula A to B is minus WL square divided by 12, and for fixed end moment for BA, B to A is WL square divided by 12. So by using this formula we will calculate the fixed end moment for AB as well as BA for UDL. So it is acting anti-clockwise, so minus WL square divided by 12. So our UDL is 20, so substitute the value. 20 into our L is 5. So 5 square divided by 12. So it will come out as here minus 41.66 kilonewton meter. Fixed end moment for span CV. For that we have the formula WL square divided by 12. Everything is same, only sign will formula is same, the sign will change, here negative and here positive, because it is acting anti-clockwise and this is clockwise. So 20 into 5 square divided by 12, it will come out as 41.66 kilonewton meter. So now we have calculated the fixed end moment for span AB, that is AB as well as BA and BC and CB. So this is our first step. So next we will move for the calculation of the distribution factors. Second step is to find out the distribution factor. Standard table for calculating the distribution factor. So here what we have to remember is, in this problem, so in this particular problem, A and C are the fixed support. We don't need to find out the distribution factor for A and C. So we have to calculate the distribution factor only at the joint. So our joint is here. B is only, we have only one joint in this problem. So that's why in this table at joint I have written only B. So B is having the member of, so our joint B is having the member of BA and BC. So how many members? It has the two members. One is BA and BC I have written. So now we will go for the calculation of the stiffness. It is denoted as the K. For that again what I have told at first. So look at here. If far end is fixed or continuous, then we have to use the height divided by L. Our member BA, our far end is fixed, so we need to use our K value as I by L. We need to use I by L. So our in this problem I value is not given, so keep it as I, and our span L length is for BA. So our BA length is total 9. 4 plus 5 is 9. So substitute 9. So it will come out as 0.11 I. So for span BC also, for span here BC or far end is fixed. So again we are going to use the same formula, that is height divided by L. So high value is not given, so keep it as high, and our span here from B to C is 5, so substitute the 5. So I divided by 5, it will come out as 0.2 I. So now what we have to do, we have to do the summation of K. It means we need to add 0.11 I plus 0.2 I. It will come out as 0.31 I is our summation of K. So now next step we will go for the distribution factor. For that we have the formula K divided by summation of K. So our K value is how much we got for DF. Our K value we got was for member BA 0.11 I divided by summation of K is 0.31 I. So by simplifying it will come out as 0.35 for our member BA. Now we'll go for the BC. DF is equal to K value is 0.2 I. So put that 0.2 I divided by summation of K is 0.31 I. So by simplifying it will come out as 0.64. So this is the distribution factor value for our member BC. This is our second step. So here one more thing is, A and C are fixed. So moment will be there in fixed end. That's why we are not considering A and C for finding the distribution factor. So here our B is, so B is injured, so it means moment will be 0. That's why we are taking B for the joint B for the calculation of the distribution factor. And you have to remember one more thing here. So when we add this 0.35 and 0.64, the summation should be equal to 1. It should not be greater than 1 or it should not be less than 1. So 0.99 is okay, but in our condition, in our problem, the summation of 0.35 and 0.64, it is coming 0.99. So 0.99 is also okay, or exactly 1 should be there, or 0.99 is also okay. So in our case our value is coming 0.99. This is how we calculate the DF. So next step is to find out in the moment distribution table. Here the one more thing is, for calculating stiffness you can also use this formula, that is 4EI divided by L. So this formula is the simplified version of this. You can use either this or this. The answer will be, you will get the same answer. Here also you can use this formula, so answer will be same, there is no different. Like this we have to prepare a table which is known as the moment distribution table. So where first row will be joint. So in our beam 3 joints is there, A, B, C. So I have written here A, B, C, and members for AB 2 members, for A joint only 1 member, sorry, A and B. So A and B, and for joint B there will be how many members for joint B? 2 members, BA and BC. So for joint B, BA and BC, and for joint C only one, that is CB. CB I have written, and the third row will be distribution factor which we have calculated. For joint A and C there is no distribution factor because here the joint A and C will be fixed at fixed, there will be moment will be there, that's why we are not considering joint A and C for calculating the distribution factor. And our joint B we have calculated the distribution factor. For BA we have the value, so for BA we have the value 0.35, so same I have written here. And for BC we have the value 0.64 I have written here. And our next row will be fixed end moment, so which we have calculated at first step. Here for AB our value is minus 61.72, and for BA our value is 49.38. in similar way I have written here all the values for AB, BA, BC and CB I have written here. So our next step is, what we have to do is, so here in this step what we have to do is, here we are not going to disturb anything about joint A and C, because our aim is to get the moment at joint B is 0. So we have to see joint B. So here what we have to do is, we have to first add these two values, that is 49.38 minus 41.66. by adding this, so 49.38 minus is there, so that minus 41.68, it will come out as 7.72. so our value is getting in positive, so make it as negative. When we get the value in, if we get value in positive we have to make it negative, and if we get the value in negative we have to make that positive. This is the important thing, we have to remember this opposite sign, we have to make it that value opposite sign. Now we are getting value in positive, so I am making it negative, minus 7.72. so it is the very important, you have to remember this. So minus 7.72. always remember that when you get, if you get value in positive sign, make it that in negative, do that in negative. So you have to put opposite sign for this particular calculation. So now our next is, so now what we have to do is, you have to multiply summation of m moment into distribution factor at this joint B. So minus 7.72 into 0.3, it will come out as minus 7.72 into distribution factor, that is 0.35. so I have written here, so by multiplying it will come out as minus 2.70, and also minus 7.72 into this distribution factor of PC, that is nothing but our 0.64. so by multiplying it will come out as minus 4.94. So I am taking only 2 after the decimal, I am taking only 2 digit. So next step is to calculate the carryover. For this what we have to do is, we have to do half of this, it means minus 2.70 divided by 2. If you do, you will get the carryover and send it to the opposite side. It means for this value here and here there is nothing, so here keep it as no. And minus 2.70 divided by 2, it will come out as minus 1.35. Send it opposite side. Here also minus 4.94, and send it this value to here, and there is nothing, keep it as nothing. So minus 4.94 divided by 2 will come out as minus 2.47. So next, so here make it one correction here. Here this value becomes 0 because our df value is 0 here. If you do summation of m into df, it will become 0. Here also the same thing happens, it will come out as 0. So now this send this 0 to here, opposite side, it will become 0 and 0. What I said first, our aim is to get the moment at B joint is 0. So now we got the 0 here. So it means we have to stop here, and we'll to last step is to find out the final moment. For that, always here one note, remember, while calculating the final moment, you should not add the value of df and summation of m. So while calculating the moment, so you should not add the value of distribution factor and summation of moment. So remember this. It means we have to only add the fixed end moment and here the carry over. So now for AB we have the value minus 61.72. Here also minus is there, so minus 1.35. So it will come out as minus 63.07. And for BA, the value is 49.38, and our summation of m into df value is here minus 2.70. So except df and summation of m, you should all the value. So our 49.38 and minus 2.70. So minus 2.70, it will come out as 46.68. So here also minus 41.66 minus 4.94. 41.66 and minus 4.94. So it will come out as minus 46.6. And here also 41.66 fixed end moment value, and here this is minus 2.47. So it will come out as 39.19. So one more thing is, when you add these two joint B, so the value will be almost 0. It will get cancelled to the value we get was 0. It means it means we have proved at joint B moment will be 0. So until we have to keep on calculating until we get the moment about joint B is 0. So now I got the 0 at first step only while calculating the carry over. So I stopped the problem here. So in some problems we don't get the value 0, moment value 0 at first step. So then we need to keep on doing until we get the value 0 or nearly equal to 0. We have to go on calculating. So in next problem I will show how to do that. I will also make one video on that. So next, now we got the final moments. So our MAP is equal to minus 63.07. It is negative, means it is anti-clockwise. Kilonewton meter the unit is, and MBA is 46.68 kilonewton meter positive, so moving clockwise. And our M, I will write it here, wait, and MBC is minus 46.6, it is a negative, so anti-clockwise. Unit is kilonewton meter, and MCB is 39.19, it is clockwise. Our unit is kilonewton meter and it is clockwise. So I have written here. So for further calculation it will be easy. So next what we have to do is find out in the reactions. For that, step 4 is to find out the reactions. To find out the reactions. So now we will take the span AB. So I will draw it here. So our span AB is here 50 kilonewton on point load is there. Here 1 inch is there. So now we got our AB value is, so now I am adding our AB value is, moment is minus 63.07. I am not writing here minus. So this symbol itself says it is negative value, and here 46.68, it is clockwise. So for here to here is 4 and here 5. So here one reaction RA will takes place, here the reaction RB will takes place. Now I will show how to calculate this. For calculating the RB, we have to take the summation of moment about A is equal to 0. Clockwise are taken as positive. So this is moving anti-clockwise. So minus moment, the moment AB is anti-clockwise. So minus 63.07 plus point load is 50 into the distance is acting at a distance of 4 meter. 4 minus RB is, so minus means it is anti-clockwise, into from here to a distance is 9 plus this is clockwise, moment BA is clockwise, so 46.68 is equal to 0. So now add it, we'll get our RB value as 20.40 kilonewton. So this is clockwise, no? It is positive. So next we'll go for the calculation of the RA. For that we have to take the summation of vertical forces equal to 0. So moving upward will take as positive. So upward here RA and RB is moving upward. So and our point load is coming downward. So minus 50 plus RB, we got the value, it is moving upward. So 20.40 plus RA is equal to 0. So simplifying, we'll get our RA value as 29.6 kilonewton. It is moving upward, it is also positive. So next we'll go for the second span. Here I will show span BC. We'll go for span BC. I will draw here. So this is inch and UDL is acting 20. So our BA, so this is point B and this is C. So moment about BC is 46.6, it is anti-clockwise. So anti-clockwise 46.6, and this is clockwise, that is 39.19. So now we'll calculate the reactions for this. So here reaction RB is acting, here reaction RC is acting. So now we'll go for the find outing the RC. For that we have to take the summation of moment about B is equal to 0. Clockwise we have to take positive. So this moment, this is moving anti-clockwise. So minus 46.6 plus UDL is clockwise 20 into at a distance of it is acting here to here is 5. 5 into UDL always act at the L by 2 distance, at a distance of L by 2. So that L divided by 2 and minus it is anti-clockwise, minus RC into distance is 5 plus this is clockwise, and 39.10 is equal to 0. So by simplifying, our RC value will come out as 48.51 kilonewton. So now we'll go for the calculation of RP. For that we have to take the summation of vertical forces is equal to 0. Upward we have to take the positive. So here RB and RC are moving upward. So now we got the RC value. I am directly writing here 48.51 plus RB minus it is downward. UDL is 20 into 5. Distance is equal to 0. So by calculating our 21.49 kilonewton. So now we got the R. So our RA value we got was 29.6 kilonewton. So it is moving upward, means it's positive. And our RB value we got was here. So for span AB we got the RB value 20.40, and for span BC we got the B value here, B value 51.49. we have to add it for span AB and BC. AB we got the B value 20.40, and for BC we got the value 51.49. So by adding it will come out as 71.89 kilonewton. It is also positive, moving upward. This is also positive. And our RC value we got was 48.51 kilonewton. This is also positive, moving upward. So next, this is the step 4. Next step 5 is to draw the SFT and BM. We'll see. So this is our beam, and we got the reaction RA 29.6. So 29.6 is our RA, and our RB we got was 71.89, and RC we got was 48.51. So now we'll draw the free body diagram of this. Here this is the free body diagram of the point load which is not at the center. It will come like this. And for this side, calculation of this side, we have the formula, that is WAB divided by L. And for UDL we have the free body diagram like this. And to find the maximum height, we have the formula WL square divided by 8. So by using this formula, we will calculate the maximum height. And now we will go for the free body diagram of bending moment. So this is the free body diagram of our point load which is not at center, and our as usual UDL. So to find out this maximum height, we have the formula, that is WAB divided by L. So substitute all the value. Our load is 50 point load. So I will just calculate. I will calculate WAB by L. Our load is 50 into A is 4, B is 5 divided by 9. So it will come out as variable 1.11. So this is our maximum height. And for UDL, to find out this, we have formula WL square divided by 8. So I will do this to here. Our load is 20. So 20 into L is 5 divided by 8. So it will come out as 62.5 will be the height. How much? 62.5. So now we'll go for the diagram of net bending moment diagram. So for that we need the moments AB, MBA, MBC and MCB. So by using this value, we'll draw the net bending moment diagram. So MAB value is minus 63.07. So minus 63.07 means it comes below this point, it comes here. And our value of BA and BC will come at, will be overlap at a single point, because our 46.68 are MBC is minus 46.6. Both will be overlap. So it will come 46 means it will comes below this point, and that is 62.5. And our MBC value will be MBC. BC value is CB. Okay. And our MAB value is 46.68. It comes here. And our MBC value is minus 46.8. It comes also here. Both will be overlap. And our MCB value will be 39.19. 39.19 it comes here. Now joint these lines. It will be like this. Now you shade this part. The part which we have shaded, this part will be negative. This part will be negative. And the remaining will be positive. So this is our diagram of net bending moment. And now we will go for the shear force diagram. In this diagram we will draw the shear force diagram. So our reaction value is at point A, RA value is how much? 29.6. So it is a positive value. It means it comes here 29.6. And from here to here is no value, so it will come like this. Again there is one point load. Now what we have to do is, I will show here 29.6 plus, it is moving downward, no? So that minus in 29.6 we have to minus this value, minus this point load. This is 29.6 minus 50. If we do this, we'll get the minus 20.4. The value we'll get the value in minus, that is minus 20.4. Minus means it comes here. Wait, it comes here. So and again here to here is there is no value. Minus 20.4 means it comes here, and again here one reaction RB is there. So now this is moving upward, means we need to add it. So minus 24.4 plus 71.89. So add it. It will come out as 51.49 positive value. Positive value means again it will come here. Like this, it will come here. And from here to here is, we have one UDL here. So it means it comes minus, it comes here. Well, what we have to do is, so our value is here 51.49 minus UDL is 20 into distance of 5, no? We need to 20 into 5. So by doing, it will come out as minus 48.51. Minus means it comes here like this. It will be, it comes like this. And again here one reaction is there, that is RC. For that 48.51, it is moving upward, no? Plus 48.51. So when we do this, we'll get 0. So again our diagram will come to touch this point. It means whatever we have calculated till now is right. If you like the video, like it, share it and subscribe for the more videos. Thank you for watching.